Hey, I hope all is well. This video we're going to look at scientific notation, and the first concept in scientific notation or objective that we're going to look at is scientific notation with positive exponents. So our goal here is to write 4,298 in scientific notation, which means that we should only have one digit to the left of the decimal when the number is in scientific notation. So most of the time when you see a number in scientific notation, um, it'll look like some number, and we'll call it C uh, point times 10 to the nth. So some number where we have only one digit to the left of the decimal times 10 to the nth power. So here, remember now, when you are moving your decimal to the right or the left, you're really dividing by 10 or multiplying by 10. So we have 4,298, and we want to rewrite this in scientific notation. So since the decimal is all the way to the right, then we know that our exponent will be positive. I'll show you why here in a minute. But our goal is for the decimal to end up between the 4 and the 2. That way we only have one number to the left of the decimal, one digit to the left of the decimal. So if I start off with 4,298, and I know my decimal is understood to be here all the way to the right of 8, I needed to make it end up between the 4 and the 2. So I move it over 1, 2, 3 places. So that's going to be my exponent. And since I started off with this whole number and I had to move my decimal over 3 places to the left to write this in scientific notation, then the solution, or the same number written in scientific notation, will be 4.28298 times 10 to the third. Now, some of you may be saying, well, you moved it to the left, so why do you have a positive 3 exponent? Well, remember, we want this number to be the same regardless of what we do. So if I were to take this 4.298 and multiply it times 10 to the third, I should end up with the 4,298. So it should have the same meaning. And remember, 10 to the third means 10 times 10 times 10. Okay, so if I'm multiplying by 10, then I'm moving my decimal back over to the right. If I multiply by 10 again, I move it over to the right one more place. If I multiply by 10 again, I move it back over, and that gives me 4,298. So it should have the same meaning. Okay. So if you have a large number here and you have to move the decimal over to the left to get it to write it in scientific notation, then your exponent should be positive, because to get it back to this original number, we would have to multiply by 10 by 10 by 10 to get it back there. All right, so this one here, we have 567.8, and we want to write it in scientific notation. So again, I want my decimal, I only want one digit to the left of the decimal, so I want my decimal between the 5 and the 6. So that tells me that I'm going to have a positive exponent. So to get that between the 5 and the 6, I need to move my decimal 1, 2 times. So that gives me 5.678 times 10 to the second. In other words, if I wanted to go back to 567 and 8 tenths, then I would multiply by 10 and multiply by 10 again. 1, 2, and that would put me back at 567.8. Okay, now writing back in standard notation, and this is you don't have to think in reverse, this is just common as to what you see. So it says write 5.981 times 10 to the second in standard notation. So scientific notation, writing back to standard notation, remember that 10 to the second means times 10 times 10. So what this really means is 5.981 times 10 times 10. That's what that 10 to the second means. So if I multiply by 10 and multiply by 10 again, the quick way to do that is to move my decimal to the right 2 places. So that will give us 598 and 1/10. Okay, so 5.88 times 10 to the fifth back in standard notation. Again, we have a positive exponent here, so I know my number should be, my standard number should be large. So to get it there, I'm multiplying times 10 times 10 times 10 times 10 and times 10 again, or moving my decimal 5 places to the right. Okay, so 1, 2, 3, 4, 5. And in those empty spaces, we need to add zeros. So 0, 0, 0. So that gives me 588,000. So if I wanted to write that back in scientific notation, then I would move my decimal to the left. 1, 2, 3, 4, 5, and I would have 5.88 times 10 to the fifth. Okay, now scientific notation with a negative exponent. So if I want to write this in standard notation, and I have 10 to the negative third, remember, going back to our exponent rules, that to make an exponent positive, then I could really write that as 5.96 divided by 10 to the third, or if I broke it down even more, 5.96 divided by 10, 10, and 10 again, or 5.96 divided by 1,000. And if I'm dividing, the quick way to do division, if you have a decimal like this, is just to move the decimal by the number of places of the exponent to the left. So you can put that in your calculator and you'll still come out with the same answer as me moving my decimal to the left for that 10 to the negative third, or to show that I'm dividing by 10 3 times. Okay, so let's fill in these empty blanks here. And since we don't have a whole number, I'm going to put a 0 here. So 0.00596. Okay. So you see here, if you go back to scientific notation, if you start off with 0 point anything, or if you have to move your decimal over to the right to get it, that decimal between the first non-zero digit to the right of the first non-zero digit, then you're going to have a negative exponent going back to scientific notation. So since I start off, if I want to write this back in scientific notation, and I start off with 0 point, then I have to move my decimal. I want my decimal to end up between the 5 and the 9. So I would have to move it 1, 2, 3 times. That will give me 5.96 times 10 to the negative third. Okay, so again here we have 4.55 times 10 to the negative fifth, which means I'm dividing by 10, 10, 10, 10, 10, 10, dividing by 10 5 times. So the quick way to do that is to move the decimal to the left 5 times. So 1, 2, 3, 4, 5. Which means I need a 0 here, and then I need to fill in these spaces. So we get 0.00004555. So again, if I want to write this back in scientific notation, I start off with 0 point. That lets me know that I will have a negative exponent, and I need my decimal to fall right after the first non-zero digit, which is that 4. So in between the 4 and the 5. So 1, 2, 3, 4, 5. 4.55 times 10 to the negative fifth. All right, so here, scientific notation with the negative exponent, we have 0.00004298. We want to write that in scientific notation. So the key here is, where do you want your decimal to end up? And I want it to fall in between those first zero digits. So I want it to fall in between the 4 and the 2. So to get it there, I need to move my decimal 1, 2, 3, 4, 5 times. And since I started off with 0 point, I know that I will have a negative exponent, because to write it back in standard form, then I would have to divide by 10 5 times to get it back in its original form. I need to go back to that smaller number, so I would have to divide by 10 by 10 by 10 by 10. So when you see a negative exponent, you know that that is a small number. Okay, I think that's the same thing there. So we'll just skip that one. All right, so application problem, type problem, converting between scientific notation and standard notation in a real world situation. So it says the total, and you may want to pause it if you want to write these down. So the total surface area of Europe is approximately 3,930,000 square miles. Write this number in scientific notation. So that's a big number. So we know that when we write A in scientific notation, we'll have a positive exponent. So to write this in scientific notation, first of all, you want only one non-zero digit to the left of the decimal. So I need my decimal to fall between the 3 and the 9. 3 and the 9 here. So 1, 2, 3, 4, 5, 6 places. 3.93. I don't need those other zeros since they're to the right of the decimal. So times 10 to the 6th. All right, B says that the signal from a certain satellite takes approximately 6.1 times 10 to the negative 2 seconds to reach Earth. Write the number in standard notation. So I know that that's a negative exponent, so I know that my standard form is a small number. So since I'm multiplying times 10 to the negative second, or dividing by 10 by 10, I'm really dividing by 100. This tells me to move my decimal 2 places to the left, since that's division. So if I move my decimal 2 places to the left, I started off with 6.1 times 10 to the negative second. One, 2. So I have 0, and then another 0. So 0.061 is the same thing as 6.1 times 10 to the negative second, same value. All right, multiplying numbers written in scientific notation. So when you multiply numbers that are written in scientific notation, then we're going to use our commutative and our associative rules first. So here I have 5 times 10 to the negative second and 9.5 times 10 to the negative third. So I'm going to rewrite this as 5 times 9.5 and 10 to the second times 10 to the third. So I will multiply the regular numbers, 5 times 9.5, and that gives us 47.5. And then 10 to the second times 10 to the third. Remember, multiplying like basis, add the exponents, so that means 10 is actually being multiplied times itself 5 times, so 10 to the fifth. Now the problem that we have here is that this 47.5 is not in our scientific notation form, because for this number to be in scientific notation, we can only have one digit, one non-zero digit to the left of the decimal. So that means my decimal needs to move over one more place. So if I'm not looking at that 10 to the fifth, that 47.5, we know it's a larger number. We have to move it over one more place to write this in scientific notation. So that part would be 4.75 times 10 to the first, keeping in mind that we already have this times 10 to the fifth from above. So now we have 4.75 times, combining these, 10 to the sixth. So another quick example here. If you have 38.3 times 10 to the third, and we need to write this in scientific notation, we notice that the 38.3 is not in scientific notation because we need only one non-zero digit to the left of the decimal. So I would have to move this over one place here. That would be 38 or 3.83 times 10 to the first times that 10 to the third, and then combine those, and that will put that in scientific notation. So just be careful with that. Make sure that your final answer is in scientific notation. All right, so here we have 9 times 10 to the 7th times 5 times 10 to the 6th. So rewrite that as 9 times 5 times 10 to the 7th times 10 to the 6th. Okay, so we have 45, which we already know is not in scientific notation, so we know we're going to have to do a little bit more work, times 10 to the 13th. So we need our decimal to be in between the 4 and the 5. So that means I need to move my decimal over one place to the left here. So we have 4.5 times 10 to the first, since I moved my decimal over one place, and then we need to bring down this times 10 to the 13th. Combine those two. You get 4.5 times 10 to the 14th. Okay. I think you can handle those now. So let's look at division, and then we'll wrap this up. All right, so dividing. So we have 8 times 10 to the 7th divided by 2 times 10 to the 2nd. Same idea here. Write the answer in scientific notation. So we have 8 divided by 2 times 10 to the 7th divided by 10 to the 2nd. So 8 divided by 2 is 4. 10 to the 2nd divided by 10 to the 2nd, using our quotient rule, we're going to subtract the exponents, and you Always want to subtract for scientific notation. Everything should end up in your numerator regardless of if it's positive or negative. So for us, the exponent. So we're always subtracting the bottom from the top. When we're working with scientific notation, you are allowed to have negative exponents. So we have 4 times 10 to the 5th. Alrighty, and the final example for this video, I have 9 divided by 3 9 times 10 to the 7th divided by 3 times 10 to the 2nd. So the same thing, divide your numbers as you normally would, 9 divided by 3, and then use your quotient rule here, always subtracting from the top. So minus 2, so times 3 times 10 to the 5th. Alrighty, I hope you found that video to be helpful. Thank you and have a good one.